Hi viewers, my name is Zishan. Welcome to Z Dental channel. Today in this video lecture, we will learn about the dental waxes and properties of dental waxes. Let's start. Dental waxes. Dental waxes are vastly used in restorative dentistry for laboratory procedures. Number 1. Making wax designs and patterns for complete and partial dentures. Number 2. Making wax designs for inlays, crowns and bridges. Number 3. Boxing in impression before our model is poured. Number 4. Registration of occlusal bite relationship. Now we will discuss about the physical and chemical properties of dental waxes. Physical properties of dental waxes. Physical properties are common to all waxes. Few important properties of waxes. Number 1. Melting range. Number 1. Melting range. Waxes may contain similar type of molecules with different molecular weight. Several different types of molecules, therefore the waxes have melting range rather than melting point. For example, paraffin wax starts melting at 44 degrees Celsius and complete at 62 degrees Celsius. Example of wax melting range. Mixing the different waxes affect the melting range. For example, range of paraffin wax is 18 degrees Celsius. When carnauba wax is mixed with it, this range increases to 44 degrees Celsius. Number 2. Thermal expansion and contraction. The waxes expand when heated and contract when cooled. This property is affected and altered when the different waxes are blended. This property is a source of error in dental procedures. When wax cools from 37 degrees Celsius to 20 degrees Celsius, contraction of 0.6% is seen. Wax pattern shrink is appreciably on cooling from solidification temperature to room temperature. Number 3. Flow. Waxes show the deformation when they are subjected to a constant load for a period of time. This plastic deformation of percentage flow depends upon temperature of wax force causing deformation time for which force is applied. Flow results from slippage of molecules over each other. Flow increases as melting point of wax is approached. Flow may be a requirement in wax at a given temperature. However, at mouth temperature, wax should not have a flow. Number 4. Internal stress. Residual stress remains in the wax pattern, no matter how carefully the wax pattern is made. This is due to low thermal conductivity of wax. If wax is heated incompletely or ununiformly, then part of the wax remains soft and plastic, while part remains hard and stress set in. When relief of stress occurs, distortion will result. Number 5. Plasticity. If the temperature of the wax increases, then the plasticity will increase. Low melting waxes have a higher plasticity. Blended waxes with wider melting range have more plasticity. First, lower melting waxes become soft with further rise in temperature. The lower melting waxes melt, while higher melting waxes soften. This results in softening and plasticity of wax. Number 6. Solid-solid transition. Solid-solid transition. When temperature of wax is raised, a solid state change in the crystal lattice of wax occurs. This is called solid-solid transition and is present below the melting temperature of wax. The wax becomes soft and can be manipulated without chipping or tearing. Wax must have a solid-solid transition temperature above the mouth temperature. Number 7. Mechanical properties. Modules of elasticity is low, compressive strength is low. Viewers, if you like this video, please don't forget to thumb up, subscribe and share. See you in next video. Allah Hafiz.